All right, question number 5. A die is loaded so that the number 6 comes up 3 times as often as any other number. What is the probability of rolling a 4, 5, or 6? All right, so let's create a sample space here, right? We know that a die has 6 sides. The sides are 1, 2, 3, 4, 5, and 6. And the probabilities, if it was a fair die, then each of these would be 1 out of 6. Okay, but it's not a fair die. So we don't know what each individual probability is. So let's just call it x, 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 but 6 comes up 3 times as often. So we can represent 6's probability as 3x. Okay. So these are the outcomes, and then these are the probabilities. Okay. Because this is the entire sample space, we know that the sum of the probabilities has to equal 1. Okay. Meaning what? 8x, right? If you add those up, you get 8x, right? 8x is equal to 1, so x is equal to 1/8. All right, so we'll go back in here and we'll replace all the x's with 1/8. So this is going to be 3 times 1/8, which is just 3/8. Okay, so just pause the video, check for yourself that if you add these up, that the sum is equal to 1, and obviously this value is 3 times bigger than that value. Okay, so now that we've got this probability model, let's move this work over to the side. Okay, let's answer the question. What's the probability of rolling a 4 or a 5 or a 6? Well, that's just the probability of a 4 plus the probability of a 5 plus the probability of a 6. Right, so we can just add those probabilities together. Okay, there's no overlap to worry about, so no adjustments need to be made, and that's going to be 5/8. See.